Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening, Dr. Elena Hyde, and I'm joined tonight by Parisa Nozari, one of our regular hosts. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. As a reminder, York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning 2 a.m. UT if that's more your speed. We do broadcast on YouTube at York U Observatory in concert with our online public viewing program run by the Observatory team, totally live. And of course, we are also recorded as a podcast wherever podcasts are distributed. So as Ellen I. Carswell Observatory presents York Universe. To navigate to the live show or to find out more or look at our cool archive episodes going back quite a ways, you can check out our website, yorku.ca/science/observatory, and follow the links to OPV for online public viewing and join the live chat on YouTube. If you have any questions or comments about our past shows, suggestions for future topics, you can always email us at observe@yorku.ca, and you can find us on social media at Instagram, York U Observatory, and Facebook at LNI Carswell Obs. All of our programs are free, but if you would like to make a donation, please see that same website I mentioned before, yorku.ca/science/observatory. There is, in fact, a fundraiser going on at the moment. So it's great to get started here. We are monitoring the chat room live if you are joining us live. And of course, we've got a wonderful show planned for you tonight. So we have lots and lots of things happening. Parisa, how is the weather where you are? Let's just see if we can get our going with our co-host. We'll find her in just a minute. Let's see here.
Oh, can you hear me now?
Yes, you're
Okay,
here
sorry.
on the episode.
Okay, great. Yeah, no, it's getting cold here as well, but
Cold
very
and cloudy.
slowly. Exactly.
No rain or snow for you yet, though.
No, that is very unexpected for November in Kingston, but yeah, no. It's -2. It was -2 today, but very
Okay,
cold.
yeah, so just a bit icy. I think that's about what we're seeing around the telescope over at the Allan Carswell Observatory as well. Little bit cold, not as cold as we thought it would be for this time of year, but far, far too cloudy for any kind of observing tonight. So we have some beautiful archive images going on the online public viewing for folks who are watching live. And hopefully next week we'll get some clear weather and we can pipe in some live views from the 1 meter telescope.
Yeah,
All
exactly.
right. Yeah. Do you have any things you like to view this time of year, Parisa?
Well, it's a very good time to see Orion as it gets very we're like in the fall and then Orion is very bright and shiny up like in the sky. So
Oh yes, classic winter constellation in the northern hemisphere. I had to get used to it as a summer constellation in Australia, but it's great to have it back up in the sky where we can go and do our tour of Orion, viewing. Um, if only the skies would clear. Alrighty, so we've got great show lined up tonight. We've got things in the sky we can view, and I guess we're going to be talking a lot about things that we probably wish we weren't viewing. um, things going up and things coming down. Um, I guess we'll go ahead and start off with your This Week in Space and Astronomy history. You want to go ahead and take it away, Parisa?
yeah, exactly. So yeah, as you said, with all those contamination of our astronomy data, with all those satellites. So I want to like also to mention that at around like November 23rd at 1962, we got a satellite called Telstar 1 command channel stop responding. But what it was actually the first active communication satellite launched back in 1962 to relay television, telephones, and fax signal across all the Atlantic Ocean, built by AT&T, American Telescope and Telegraph Company, and also NASA. And this satellite was a true game changer at that time to see all those first live television broadcasts all across the Atlantic Ocean. But we might
Well,
not
just
think,
to say it was
yeah.
telephone and telegraph.
Oh,
So make sure we'll make sure to get that right. It was a little too early for it to be a telescope company, but it was the telephone and telegraph. So starting off from early times, communicating, it has some fun history as well. But let's get into those satellites.
yeah, exactly. We don't think about like the satellites on our day-to-day base life, but they actually plays a huge role in guiding our GPS, the beam TV, or our homes. And they actually even help us to predict the weather. But actually, where it all began back on October 4th, 1957, when the Soviet Union launched Sputnik 1, kind of like a shiny metal ball about the size of the beach ball into space. And that was like the first humanity's artificial satellite into the space. And it just simply sent out some radio beeps and captured the words, like basically imagination. And people everywhere at that time just turned their radio to hear those beeps. Sputnik didn't do much, but it showed that space cannot just be a dream and we can actually sense something up there.
Oh
So
yeah, and it was very exciting because 1957, well, 1962, Telstar was really a big first. But in 1957, picking up something from space on your radio, crazy. And that's why you see a lot of astronomers who like to have their signature as a beep, beep, beep. And it was something that anybody with a radio would have been able to pick up on if they had a strong enough radio receiver. So it's really captured the imagination is I think underselling it a little. Very exciting stuff.
oh yeah, just like imagining like back in like the time that we even could like have think of a smartphone, we just had some signals from space. That was just very, very impressive. But yeah, that was very cool. So just a few months later, on January 31st of 1958, the United States joined the space race with Explorer 1. And that wasn't just any satellite. It was the first time that we carried instrument that made the first major scientific discovery in space. That we know them as Van Allen radiation belts. And that Van Allen radiation belt is a zone of energetic charged particle, most of which originated from the solar wind that are captured by and held around a planet by the planet's magnetosphere. And Earth has actually two such belts, and sometimes other may be temporarily created and destroyed. But the belts are named after James Van Allen, who published an article describing this belts in 1958. So that will be like the first discovery of like of a satellite been to the space and actually do something.
Yeah, and I mean, those satellites as well. These early satellites, we were able to count, sort of on one hand how many were up there. Sputnik 1, for example, I mean, it was fairly safely deorbited, um, and it came in and burned up in the atmosphere reasonably safely. And we had, even at the time, people were worried, would it come down in a populated area? How much damage would it do? Because it was, I mean, obviously this was a bit of political as well. So, they're worried that people were going to send things up there and then crash them down other places. Um, but satellites getting started here, as you say, um, the first few that came up were so very very exciting for very very good reason because we had for the first time ways to communicate around the world that were faster and more reliable and of course led to GPS and as you say, the Telstar 1, was, a huge sort of financial satellite communications project that, was probably a precursor to some of the satellite communication excitement that we're seeing today. So I'm not sure how much of the Telstar 1 safely deorbited actually, but it did have, first pictures coming back and, relaying data between computers. That's very, very exciting stuff.
Yeah, exactly. So by that time, around like 1962, as you like mentioned, like when the Telstar one coming out was the time that satellites just got smarter and smarter over like the decades after. And then the first satellites to rely like live TV broadcast and just imagine like watching news like reporters like live from the across the ocean at that time. That would have been like such mind blowing for people back then. And yeah, so and then fast forward to 1970s and the satellites like those in the GPS constellation were changing the way we navigate. So we by that time that we got introduced in concept of like GPS, and today we can get direction anywhere in the world like in a second, and thanks to those or very early innovations of satellites that we could map Earth pretty much more precisely and then update it. So right now, I'm pretty sure that like every second, like the maps are changing like in a second. So the maps that we're like having in our Google Maps is not like the same that we had like for example half an hour ago, because all those data are updating very very fast, and that's very just fascinating to see
Oh,
how
how
these
many,
data.
how many satellites exactly? And that's something to note. So you were talking, of course, about early days in the space race. We had, satellites we could count on one hand, but by the time we had Telstar, we were already seeing a bit of an explosion. And just a few years later, by the time we got to the 90s, they were counting in the 7,000, over 7,000 objects in space. Of course, now we know it's much, much more than that. Now we're looking at, 1990s, around 7,000. We got up to 10,000 in 2005. In 2016, we're looking at 17,000. And then, of course, the Starlink, which we'll be talking about a lot more. But in 2022, we were already approaching 32,000 objects. And every time one of these collides or is exploded by someone firing a rocket at it, um, which does happen occasionally, um, it creates a cloud of debris. And it was actually, we'll talk about the news from some of that later. So it's been really really interesting to go through and see how these satellites have developed and how the space junk problem has continued to grow and grow. And since we've gone through the sort of up through the 60s and 70s, I thought I would put something that will get us a little bit in the middle. So I'm going to take us to This Week in Space and Astronomy History, 26th of November, so that's tomorrow, but back in 1989. So not quite as far back as Parisa went. But same era, just a little couple years later, we now have a good amount of stuff in space and the Muir space station. Talk about some big pieces of space junk. In the 26th of November, we had Muir being built actually, and this was the launch date for the Cavant 2, which I'm probably saying wrong, but this was the third module and second major addition to the Muir space station. And if you haven't heard about the Muir space station, we'll do a little aside into that because it is, or it was, it was really, really cool. It was the first real place where humans could live in space for long times and the first records for the humans continuously inhabiting anything in space were all set at Muir. And it held the longest continuous human presence in space until 2010, so very recently. So the Muir longest human in space was 3,644 days, which is a long time to be up in this uh, very early, very early space area. So Muir was quite an interesting program in and of itself, and of course the Cavant 2, which is what launched, was basically there to deliver new science experiments, better life support systems, very important, an airlock to Muir, and it launched in 1989 on again tomorrow on a proton rocket. And we've talked about rockets a few times on the show because rockets are integral into getting things in space, and it's something that we have to think about when we talk about space junk as well, because of course the boosters come down, and sometimes the whole rocket comes down, and of course using larger and larger rockets means you can launch more and more things into space for better or worse. So the Proton was a pretty nifty one that was basically an expendable launch system used by the Russian government. The Mir was mostly Russian. It was collaborative agreement, but the it was really Russian led, and so Kvant 2 also docked in, got attached to the Muir space station, and it had a lot of fun stuff. So there was a bunch of instruments which we're probably not going to have time to go into, and we'll talk about a few of them. But it also came up with an airlock, so it had a backup area, and of course it had quite a bit of work to be done to actually attach it to what was at that time basically the beginnings of the Mir space station. Once the Cavant 2 actually got fully working up on Muir, the whole space station got a lot nicer to visit because it did have air cleaners and a bunch of fun stuff. It had Earth resource film cameras because of course they were still using film for a lot of cameras. They had spectrometers to look at light in different wavelengths and of course try to see what types of things are there, looking at the atmosphere and stuff like that. It also had cosmic dust detectors because there were some pretty fun experiments being done looking at what kind of dust would be out there. The Cavant 2 was a great success for Muir, and of course Muir itself was a great success, being in orbit for 15 years, which is quite a record. And I will just go ahead and say that as a little bit of a rounding off, the Cavant 2, it you know, it basically was kind of what really brought the Mir space station to life in a lot of ways. And the Mir itself lasted until about 2001. And Mir's deorbit was carried out in 3 stages because it was quite large at that time. So they had many modules, they had giant solar panels. So first they had to wait for the atmospheric drag to reduce the station's orbit. And atmospheric drag is important whether you're talking about a space station, a satellite, or a small fragment of something that's broken up, so a small piece of debris. I think they've measured them down to microns by now. So atmospheric drag can take something that's in orbit, in sort of low Earth orbit especially, and provide a little bit of friction, which is going to make it lose velocity, which is going to make it fall into the atmosphere more, which is going to make it basically crash. So if you want your thing to crash on a planet with an atmosphere, the drag will help. They actually started off docking a Progress M15, which was carrying 2.5 times more fuel in place of supplies, and then they were able to use that with 2 burns to sort of force it into land finally. And of course, the Muir also, once it was all done, they kind of replaced it with the modern ISS, and there was a pretty famous landing of uh, part of, gosh, what was it? I forget the name now. One of the capsules in Australia. around that time. So what they were really worried about was that it's so big, right? If you have this thing decelerating through the atmosphere, it's going to reach critical velocity, and of course, when it crashes, it's going to crash pretty hard. So they did actually want it to make sure to hit you know, unoccupied piece of land and not a city, for example, which is, and actually at the time they were worried about orbital debris for Muir as well because low Earth orbit has more orbital debris due to more collisions because of the atmospheric drag bringing more things in, and it's pretty interesting. Do
Yeah,
you have
that's
any
just
favorite? Oh yeah, go ahead.
yeah, no, I was just wondering to say like that's just crazy how like violent those atmosphere like or atmosphere of like the earth, but also like the space is that it can just like, make all those like crash and collisions that yeah, it's not really like a calm place.
Yes, exactly. Well, and especially low Earth orbit, they have a lot of problems. And I was trying to make a Skylab reference earlier. Sorry for just spaced the name, which is funny because it's in space. So Muir came down relatively safely, but it was Skylab that actually crashed onto land in Australia. Um, and there are still people debating whether or not it was an accident, especially in Australia. And I can say that because I used to live there. So I'm Australian as well, and I can tell you that the Skylab space station collision has quite a history, and there was a whole, at that time, this one was, not of this week in space history, but it was 1973, so around the same time, massive piece of equipment comes down, the whole Skylab thing, and when it crashed into Australia, it hit the land, and they actually had a bit of a treasure hunt happening over it. There was a sonic boom. They were really lucky it didn't actually land in the town, but they got a whole bunch of souvenir hunters racing around the Australian outback in Jeeps and Land Rovers trying to grab pieces of it. And it's an interesting story of space junk, but also a really, really lucky miss because, of course, if it had hit an occupied area, that could have really done some damage. And what we're seeing now with the larger space debris coming and crashing from SpaceX, it makes us, maybe remember some of these earlier incidents and go, oh, right, there's more of that now.
Yeah, exactly. I was wondering like if they can I'm not sure if they can predict all the pieces that if like on the explosion the like by I am pretty sure they can calculate the I don't know, like how far maybe that explosion leads like the pieces, but I'm not sure
Well,
like
you know how big of danger it is by how large it is, right?
exactly.
But uh, that's one of the problems with, of course, getting space junk uh, that smashes together. So I think that's going to get us to your next item actually really well because
Yeah.
you've got something to talk about with this with
Oh,
space junk and orbiters.
yeah, exactly. So it was just like you always like using that analogy that spank junk is like our attic that we kind of like forget how much stuff we left at that place and then we go back and like looking at that. So for example, like on November 26th, like 1959, one of those first few like actually like debris and space junks was from the United States launched a Pioneer a P3, a lunar orbiter that it was designed to study the moon closely, kind of like a groundbreaking mission for its time. But then just after 45 seconds after its launch, the spacecraft's protective cover called the payload shroud failed, and that caused the rocket's upper stage and then the probe to break apart and ending the missions like very, very early. So that was like a fail, and then just explode and then left a lot of debris. But then since Sputnik back in like 1957, we've sent up over like 11,000 satellites, and many of them are no longer working. So just imagining like how much space junk are like already like up in the space. And along with old rocket parts and fragments from collision, these pieces of debris are floating around Earth. In fact, as of 2017, there were almost 20,000 pieces of space junk being tracked with a combined mass heavier than Eiffel Tower. And that was just insane to think about it. And then imagine kind of like driving in a highway packed with the broken down cars. And then now imagine these cars are moving 10 times faster than a bullet. And if they crash into each other, they create like even more debris. And that's exactly what's happening in the space right now. And in 2009, um, like a Russian satellite smashed into a US satellite, creating over 2,000 pieces of a debris. And so we need to also like be very careful when we launching a new satellites and taking into account that there are so many debris like floating around the earth. And just for those people who launching like new satellites, they need to take that into account. But it's not like that bad news, because space agencies like ESA and NASA are working on solutions. I think they're really at the early stage, but there's something called Clean Space Initiative, which is like a giant space cleanup crew that they're trying to testing new ideas like nets, robotic arms, and even lasers to remove debris. Plus, new satellites are being designed with the self-cleaning features that some of them just burn up in the atmosphere, Earth atmosphere when they're done. So they
Yeah.
can avoid, yeah, just a lot of like their leftovers and debris before going to space, or just leave some of them in Earth atmosphere.
Yeah, well, the great advantage is once you get into Earth's atmosphere with your little debris piece, the atmospheric drag will do the work to bring you pretty much the rest of the way down. Unfortunately, there's so much debris now. It's really gotten to a whole new level of issues. And I thought, it's you mentioned ESA and NASA, and of course they have debris surveillance programs. But it's worth noting that the particle size of these debris, some of them even get quite small, and the small particles would be much easier to remove with something like a laser, because if you hit one of the particles with a ground-based laser, which of course there have been people experimenting with this. There are some very strong lasers that go to the moon and back actually to measure its distance. But if you were to hit a small piece of debris with a laser, you could kind of try to push it basically into the atmosphere. And some of these debris are, very large. Some of them are 10 meters in size. Some of them are 1 meter in size. Some of them are 10 centimeters. Some of them go 1 centimeter all the way down to microns, fractions of a fraction of a centimeter. So you get down to maybe even just 10 microns, incredibly tiny, 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 tiny pieces. And even those very, very small pieces, they're traveling so fast occasionally that they still pose a significant hazard to things like astronauts. There are people up on the ISS now who are, going to have to worry about that. And any entrepreneurs wishing to build a space hotel, I think I saw a design that was like a circle inflatable. Anyways, it would have to go in low Earth orbit almost certainly, and that's where a lot of the debris is. Um, so, we still don't know where all the debris is. There's so much of it, we can't actually track it. And the more that it collides, the more debris it makes. And so at some point, in theory, if we keep launching stuff and it keeps colliding, we're actually going to end up with a situation where we have a nearly impassable debris field of our own making. So hopefully the Clean Space Initiative does decide to take over, or we come up with some good international space law to sort of put some cleanup initiatives in place, especially now with the thousands and thousands of new satellites being launched. It seems like every week now.
Exactly. So one problem is that because like the space science and space satellite and rockets are very kind of like limited to a few countries, and it was not done before. There's not much of a regulation or a law on that, so we still like exploring and figuring out what works and what's not. But I think I'm afraid that like until the time that they set up some restriction, that would be like a little bit too late. But
Yeah, that's the danger. I mean, and humans have been have been known to wait and wait past the good amount of waiting time for things. So, you know, there's over 30,000 pieces for sure that we know of. And that's not counting the 128 million pieces of debris smaller than a centimeter. We don't even know how many, but definitely over 128 million. That's a lot. And I know we say all the time, space is big, but low Earth orbit isn't that big, and it is getting very, very filled up. And it's, you know, not only the new satellites' fault, although the new satellites are a lot. You know, there's for every couple, you know, thousand active satellites, there's also inactive satellites, and the inactive ones are really, really dangerous because, of course, they're not controlled and nobody's monitoring them. So having things that can watch satellites and track dangerously large pieces of space junk is actually great. And I'll just give a little plug for our wonderful 1 meter telescope, actually, because we have actually done satellite tracking over at York University. And it's something that folks with smaller telescopes can help with if for larger satellites. So if you want to track an inactive satellite just to see if it's going to collide with something, there's actually some programs you can join for that. So it's a little bit of community science that you can also join in with if you're keen on watching satellites go around. You do have to get special tracking for them though, because of course they don't move like they should. And there's some great animations you can find online showing the real quite substantial cloud and debris and how much have been tracked and how much they still can't track. But at the moment, a lot of the plans are still saying like, you know, 25 to 30-year sort of plans for removing older space junk. So I have to say I'm not sure, but I hope that we will get a space junk cleaning program up and running.
yeah, exactly. There's so many that honestly, I think I heard that Astronomical Society of Canada, they're like in the some kind of like action to find some I don't know, like to work with some lawyers to go and against and some like to just say stop on like the number of satellite that we're launching, because it's also like contaminating our astronomy data set so much. And it's honestly it's impossible to observe with the big even telescopes, or even like going for stargazing, just a chill night. You cannot skip not it's not seeing a satellite. They're everywhere.
Yeah. But a lot of us who are trying to get pictures of the comet with a wide field lens really saw that problem. I mean, it's become a verb now. You're not just observing. You're getting Starlinked, um, because these, especially when they're still grouped in the cluster, they come through a field, and there's really no avoiding them. But yeah, there are some good Canadian space junk advocates. Actually, there was recently we talked about it a little bit ago on this show, but if anyone hasn't heard, a bunch of space junk actually fell in Saskatchewan not too long ago, earlier this year, and two men with SpaceX actually came in and collected the over 40 kilograms of burned charred metal. And That's really quite lucky that it landed on a unoccupied part of the farm. So again, very heavy, dangerous stuff coming down. And again, this year we had a actual piece of debris come through a house in Florida. also from SpaceX. So unfortunately, we seem to be talking about them a lot because they have been contributing a lot to the space junk coming down um, in uncontrolled deorbits, which is also known as just crashing. All right. Well, I think we got time for one more quick This Week in Space and Astronomy history. I thought I would end with one happy thing that comes down, just because not everything that comes down is bad. Something that we generally don't have to worry about because there's a lot less of them are meteors. So meteors also have the same problem with Earth that satellites do, is that if they get too close to Earth's atmosphere, the atmospheric drag can bring them down. Meteors and meteorites have been fun for people for basically forever. There's been very, very few close encounters with a meteor for any humans. There was famously one person in North America had a meteor come through her roof and almost hit her leg, or hit her leg at a glancing blow and made a bruise. And that's so far the only known meteor injury that we have. But I'll go back in time just for a little bit of a fun way to end this, because of course we don't want to be all doom and gloom. But the 27th of November, so 2 days from now, in 1885, the first known photo of a meteor shower happened. And this is just a really fun one. So this is, of course, 1885. Photography is a very young field. And on November 27th, a astronomer was trying to get pictures of a meteor. And this was taken, the picture itself was taken by Austro-Hungarian astronomer Ladislav Weinik, and he captured the trail of a meteor on a photographic plate in the Czech Republic. The meteor he captured was actually part of the Andromedan meteor shower. The Andromedids were associated with Biela's comet, which broke apart in the 1850s. So, slowly getting worse and worse over time. And when Weinik observed the meteor shower in 1885, it was in the middle of a meteor storm. So there was a lot more meteors than usual. Skywatchers could see thousands per hour. And what used to be a spectacular annual meteor shower is now hardly even visible. You won't even hear the Andromedids. I mean, maybe you'll hear them mentioned, but only in passing. So instead of photographic plates or digital cameras, we now would have to use special tracking equipment if we wanted to get any images of Andromeda meteors, because of course they don't get refreshed like so many of the others. And I thought it would be just fun to remind folks as well. If you are interested in meteor showers, just a little bit of FYI, we have just had the Leonids come past November 16th to 17th in Toronto. So if you are in Ontario, Toronto general area, and you missed the Leonids, your next chance is going to be the Geminids. And the Geminids are actually visible north and southern hemisphere, depending on, of course, your exact position. But for Toronto, it'll be Friday, December 13th to Saturday, December 14th, and they'll be about 32 degrees above the horizon. So seems like a fair meteor shower. We don't actually know if it's going to be amazing or if it's going to be, ho hum. You don't really know until you get there, because meteor showers are notoriously unpredictable. The Geminids in particular will look like they're coming from the constellation Gemini, and they're not associated with a comet, so they're also a little bit interesting. They're associated with an asteroid, 3200 Phaethon, that takes about 1.4 years to orbit the sun. Now, that one hasn't broken up, so it does get refreshed. And if we're lucky this year in December, the the December meteor shower might get up to 100, 150 even meteors per hour at its peak, which would be pretty good. So definitely check that out if you're not afraid of getting really, really cold on Friday, December 13th. And these are generally very, very small particles, but if you do see one come down very spectacular with red and green and blue or colors attached to it, I think more green than blue, but that tends to be a bolide. Those are larger pieces of rock, and sometimes those pieces hit the ground, but usually they don't. So I just thought it would be fun to end with something a little bit more upbeat for this week's space and astronomy history. Little shout out back to 1885. Now, I just have to take a second to remind everybody we are, in fact, listening, or you are listening, we are talking. You are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are interested in browsing the archives, you can always see yorku.ca/science/observatory. And of course, tonight you're listening to Elena and Parisa, and we're discussing space junk and things that come down. So, if you're joining us from the recorded version or from the podcast, FYI, you can always click on the online public viewing for the live show every Monday night at 9 p.m. Eastern Time. So we have a little bit of an announcement, and then we have some fun news items to go into. The announcement for this week is pretty similar to last week. It's actually an announcement of a first ever Allan I. Carswell Observatory online fundraiser. That's right, an actual fundraiser. So just in case folks didn't hear the website before, our online fundraiser is at yorku.ca/science/observatory, and then you can click on the fundraiser, or you can add an extra slash and go to AICO minus sign fundraiser. I'm never sure if that's a dash or not. So the fundraiser is an effort to continue our free tours, create some awesome swag, refurbish the wonderful 40 centimeter, repair the atrium, and lots of other stretch goals. Free prizes at every goal and special events. And I'll just give a little shout out. We are almost halfway to our first goal of $5,000. If we get there, we will be drawing a private tour raffle. So we'll be drawing a private tour raffle for every goal that we reach. And we will be drawing a supported observation raffle. That's right, you could win a supported observing evening with the AICO crew. The data will be your own after the observation, and one raffle winner will be chosen for every goal we reach. So if we get to 5,000, we'll choose one person from each raffle. And if we get to 10,000, we'll choose a second person. There's also free digital swag and pass out materials at every goal. So if we get to the first goal, we'll also be publishing our astronomically accurate fortune teller on the website for everyone to download. And we'll print out 400 observatory bookmarks to give out for free. So more free stuff in case the free tours and the astronomy podcast wasn't enough of a draw. If you want to find out more about all of our goals and what we could do with different stretch goals, including renovating our atrium facility, getting a new fireball computer, maybe naming it something else, and maybe even getting a Skyshed pod for the 40. So all of that's on the website, and it's going to run until January 5th, at which point we'll close the goals, but donations will be open all year round. So anyone looking for a tax deduction or a reason to donate and enter the raffle, please feel free. We have a special YouTube program this week on Friday as well. Friday, November 29th, we'll have two special guests and a series of Astro News items for a special fundraising event on YouTube from 7:30 Eastern Time, November 29th. So that's all the fundraiser news and a little bit longer reminder than we usually do. So hope everybody got all that. Now, on to some regular news, astronomy news. So we've got lots and lots of things in astronomy happening. We can't possibly talk about all of them, but Parisa, I think yours looks amazing. So why don't you go first?
Yeah, so back talking about SpaceX again. Actually there was a news coming out today that NASA awarded SpaceX a contract worth about $256.6 million for the Dragonfly mission to handle the launch to explore Titan, Saturn's largest moon. And this project is managed by NASA's Johns Hopkins Applied Physics Laboratory with other contributions from NASA's Kennedy Space Center and Marshall Space Flight Center. And Titan, the largest moon of the Saturn, is very fascinating with a thick atmosphere, rivers and lakes made of liquid methane and ethane. It's one of the most in very like one of the most places that everybody's curious about in the solar system when it comes to the possibly of life. So, what is this dragonfly? This is a rotorcraft lander, meaning it's kind of like a drone that can fly from place to place. And this mission will study Titan's surface, sampling materials and analyzing its composition in various locations. And by doing this, astronomers hope to uncover clues about how the building blocks of life may have formed here or whether signs of life might still exist. And this spacecraft is set to launch sometimes in July 2028 aboard a SpaceX Falcon Heavy rocket from NASA's Kennedy Space Center in Florida. And this rocket, known for its incredibly lifting power, is perfect for delivering Dragonfly on its long journey to Saturn. Now this isn't just another space mission. Dragonfly is also a part of NASA's new Frontier program, which funds bold and innovative mission like the New Horizon flyby of Pluto and the Juno spacecraft currently studying Jupiter. And then Dragonfly is the program's fourth mission and represents a big step, basically, to how we explore Saturn atmosphere. So instead of like a rover crawling over the Terran, like this drone will be fly across the surface. That will be very exciting for basically going more in details to figure out what's happening in Titan.
Oh yeah, absolutely. And of course, we've seen the little. I mean, I hope everyone has seen our favorite little Mars helicopter adventures. This is a very, very new technology. The first ever actual flight on another planet is very, very recent. This is the Ingenuity helicopter that operated on Mars all the way through this year. Ingenuity made its first flight on back in 2021, and of course it came as part of a joint mission with the Perseverance rover. And this was a little tiny, tiny, tiny helicopter. And there have been so many proposals over the years for different kinds of ways to do flight on other planets. They had glider plans and all kinds of things. And I have to admit, I was a little bit surprised by the design of the helicopter for Ingenuity, but it's been so successful. There are some amazing, amazing videos of that this little tiny helicopter took, and it was such an astonishing success. They were planning to maybe it would fly a few times. It's over 72 flights in 3 years. So they've actually built on that a lot for this design, I would have to say. The Dragonfly, not to be confused with other Canadian Dragonfly missions that are happening, University of Toronto, um, but this Dragonfly is, to me, it actually looks very, very similar, some of the concepts that they've drawn up for it. And I wouldn't be at all surprised if it had a little bit of Ingenuity, um, uh, sort of built into it. But it's such a cool idea. And I'm really, really glad to see them starting to use things that will allow for larger exploration. Because as you said, walking around on the surface, boy, you're just not going to get that far. So this is great. It'll be able to fly across Titan's atmosphere, and we'll actually be able to map it out, I hope. And Titan is such a real enigma. I mean, we had the Cassini-Huygens, so we're a little bit spoiled for Titan data, but this is the only moon with an atmosphere, a real atmosphere. Crazy.
Yeah, it is so exciting because I assume like when the technology it also gonna bring all those atmosphere study, or even like study the gassy planets more in details, because we actually can just orbit around them and then just flying, or if, like in any kind of like, I don't know, maybe it just like sounds so far, but maybe just like sending some to some exoplanets. But
That
we can
that might
always
be a
dream
little
about it.
farther, yeah.
Yeah.
And this is I mean Titan is the other natural other natural candidate for this kind of craft because Titan is the only thing that has an atmosphere we can fly in other than Earth and Mars. I mean, Venus's atmosphere is so extreme. There have been talks of maybe a blimp or something, but it would be a real challenge. And of course, all the Jupiter and Neptune and Uranus. Well, Neptune and Uranus are critically underexplored, but their atmospheres are all much thicker and more unknown. So this being a relatively well mapped atmosphere and a really really interesting one, it is just so literally cool. And it's worth noting as well with Titan, the chemistry is so different on this planet because its atmosphere is extremely cold. It's got nitrogen and methane with hydrocarbon clouds. It's got liquid hydrocarbon lakes. It would be such a strange place because it doesn't have a water cycle, it has a methane cycle. It's just I am 100% for this mission, so I hope they make it and don't blow up in the atmosphere.
Yeah, I hope too. I also have one other news that on November 19th, 2024, like just this November, the SpaceX successfully carried out the sixth test flight of its Starship Super Heavy rocket. And this rocket is a part of an like ambitious project aimed at creating a fully reusable spacecraft capable of supporting missions to the moon, Mars, and beyond. And then the recent test of, evaluated the rocket system and contributed to advancements in its design and operation. But then each test basically, of course, is necessary to take that steps closer to making Starship operational. But basically, the Starship is a two-stage rocket system, the lower part called the Super Heavy Booster, and it's designed to lift the spacecraft into orbit and then return to Earth for reuse. And reusability is a key goal for them, and that can reduce the cost of space missions so much. But the problem is that SpaceX is already known for launching satellites, and since its funding in 2002, SpaceX has launched over 5,000 satellites, and with most of them forming the Starlink network. But it aims to build a mega constellation of around 12,000 to 42,000 satellites by 2030s. So that's a little bit, I think, concerning to me. But Starlink is a constellation of the satellite that it's designed to provide a high speed internet across the globe, even to very, very far remote areas. And these satellites are usually launched with the Falcon 9 rockets, which have been successful very so far in terms of reusability and efficiency. But then it could carry, if once fully operational, this project, it could carry much larger payloads, including hundreds of satellites in a single launch. Because currently they will successful to compare to 60 or a little bit more than that Falcon 9 currently will be able to like handle. And this make this deploying satellites constellation like Starlink faster and more efficient. But like that number is a bit large to me, and I hope
Yeah, that's a
they
little
they find some
concerning.
solution. Yeah.
Yeah, and I mean it is concerning with for the space junk problem in particular. The rocket technology is really interesting, because as you mentioned, Falcon Heavy has really become a very very well respected launch vehicle. Over 11 launches now, I think, and if they're able to get Starship reliable, it's going to be one of the the most capable lifting tools we have ever seen. Because back in the day, when we're talking like we're talking about the 70s, and of course there was a space race, we had Saturn V. And Saturn V could lift some stuff into orbit. But now we don't have that. We've got the SLS and various other things. But Starship is really what they're hoping is it's going to be able to provide substantially more lift and be reliable. It hasn't really got there yet. And, it is interesting that, it's like, oh, you could do so many wonderful things. But as with any other tool, you could also do some bad things. So I think that'll just take us to the very last little news item, which is, space junk. We've seen this year, literal giant chunks come down in our own backyard over, well, if your backyard is Saskatchewan. We've seen space junk really start to pose a problem, and this is before the Starlink and the other companies who are also now saying they want to make satellite constellations as well. Just recently, on November 19th, I'm just checking, yeah, November 19th, the Progress 89 thrusters were fired in an emergency maneuver at 2:09 p.m. CST for 5 minutes and 31 seconds to raise the orbit of the International Space Station because of a pile of orbital debris. And this particular pile of debris was they were able to determine it was from a defunct Defense Meteorological Satellite that broke up in 2015 and is still around. So they were actually able to identify it, which is amazing, see it in advance, and maneuver around it. And this is called a debris avoidance maneuver. So you guys can make that acronym yourself. I don't think I'm going to say it in a recording. It was conducted in coordination with NASA, Roscosmos, and the other space station partners. This is not the first time the space station has had to go into emergency mode because of debris. They actually calculated that with this maneuver, the fragments could have come to within about 2.5 miles of the station, which it seems far, but it's really not for space. And they said, okay, it's all successful, it's all fine, we made it. But I did think it was very interesting that just now we've already seen the all kinds of space avoidance problems, and literally just a couple days ago, the space station had to jump out of the way of a giant pile of debris. So it's been an interesting journey. And of course, the European Space Agency, in response to this, put out a study that they say that there are probably over 170 million pieces of debris larger than a millimeter, 670,000 larger than a centimeter, and over 29,000 debris pieces that are over 10 centimeters. So all of those would be bad for the ISS, the International Space Station. And this is, something that we've talked about. I think a good point to end this show. As more and more debris enters low Earth orbit, this comes about, and there's a prediction called Kessler syndrome. This is when the amount of debris causes a cascade of collisions, which results in more debris and more collisions. In the worst case scenario, the Kessler syndrome theory predicts that Earth's orbit would become filled with debris, making it unusable for satellites or spacecraft. This is actually debated, but everyone agrees that tracking is insufficient. So we do need, whether it's an international agreement or a new space law, we definitely need something in there. So on that happy note, thank you, Parisa, for joining me tonight. It's been great to have you back on as co-host. We're going to go ahead and round off the evening here. And thanks all of our listeners. You have been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Parisa Nozari and myself, Dr. Elena Hyde. You can always connect with us on Instagram at YorkU Observatory and Facebook at Allan I Carswell Obs. Check out our website for show notes, content updates at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.